Hey guys, I just want to spend a little bit of time talking through a couple of important ideas. Um, the first, as you can see, comes from our carbon cycle quiz. A couple of really important things that were missed by many of you that I wanted to just go over. This top graph is going over the amount of carbon dioxide in the atmosphere in parts per million from 800,000 years ago to the present. The second half of this graph deals with Antarctic temperature during that same time frame. Well, um, the really important thing that we need to understand and notice here is that whatever the carbon dioxide does, the temperature does as well. So if CO2 goes up, temperature goes up. There's a direct correlation between the two of these variables. Another important thing to gather from this graph is that about every 100,000 years we go from a peak in both carbon dioxide and temperature down to a minimum, back up to a maximum. And it's a cyclical pattern for the last 800,000 years. So what that means is we haven't had anything to do with that, we being humans. People have been around for 800,000 years, but as far as we can tell, there's been no change in that cyclical pattern. Okay, so as far as climate change goes, this climate change, which it is changing, it's going from warm to cold back to warm, is completely natural. It deals with those Milankovitch cycles, changing the tilt, the orbit, and the wobble of Earth and its relationship to the sun. Okay, so that's what we've noticed for the last 800,000 years. Completely natural cycle. However, when we take a look at this bottom graph, we see that the global carbon emissions, okay, emissions being things that carbon dioxide being emitted into or put into the atmosphere since 1850, which is super duper close to the end of this top graph, has been increasing exponentially. Okay, to the point where we're almost up to 8 gigatons. Well, we are past 8 gigatons now of carbon dioxide being emitted into the atmosphere, which is completely unnatural compared to what we see up here. Okay, so one of the biggest things I was trying to get you to understand and use these two graphs, not just the one down here, is for the last 800,000 years, climate change has been completely natural. The amount of carbon in the atmosphere has fluctuated from a max of close to 300 to a minimum of 150 or so. But if we take a look at the carbon in the atmosphere now, it's like nothing we've seen for 800,000 years. And they talked about that in Secrets Beneath the Ice. Okay, so really make sure you understand this relationship and what's going on here. If you have questions, make sure you ask. The second thing I wanted to talk through was the first explore activity. Okay, so I'm putting a key to this in Schoology so that you can go back and take a look. Compare your notes to the notes that are here so that you've either grabbed what you need to, the essential information, or if you need to add to it. Otherwise, it asks you to create flowcharts, and I noticed a lot of us didn't know what a flowchart was. A lot of us drew diagrams of the carbon cycle, which is good, and it's important that you understand that, but a flowchart is very different. It looks more like this. Okay, so we started out in the geosphere, right? And we end up, in this case, in the biosphere. Okay, so how does it get there? Well, we're going to burn those fossil fuels. Some people started with the geosphere releasing CO2 into the atmosphere from volcanoes, and yes, that does happen, but we're focusing on this unit more on the human impact. Okay, so burning of fossil fuels goes into the atmosphere, and for this specific flowchart, we're trying to take a look at how does that excess carbon dioxide in the atmosphere impact organisms in the biosphere, specifically marine organisms. So a lot of that atmospheric carbon dioxide then is diffused into the hydrosphere. Okay, so yes, it does increase the temperature of the atmosphere because there's a greenhouse gas, but a lot of that is diffused into the hydrosphere, which then mixes chemically with the chemicals in the ocean, producing a lot of carbonic acid. Okay, and there are a couple of important consequences of that carbonic acid. Some of it deals with making it more difficult for organisms to create or generate their own shells, and they spend a lot of energy creating shells that are a lot thinner than what they're used to. And second, that increased acidity dissolves carbonate, which those shells are made of, okay, making them even weaker. Okay. Not only that, but it also has a huge impact on coral reef ecosystems. Kind of the same deal. It's dissolving the framework of those coral reefs, which coral reefs don't make up a large portion of the ocean or the ocean ecosystem, but they house or are home to 25% of all marine species. The second flow chart, again, started with the geosphere, but then is bringing us back through the atmosphere, biosphere, and ending here in the atmosphere. Okay, so again, burning fossil fuels, right, making the temperature warmer, but that also, that increase in CO2 is good for plants. That's what they need to generate their food. So through the process of photosynthesis, there's a huge increase in biomass in terms of plant material. However, either naturally through wildfires or controlled burning by humans, that biomass needs to be taken care of. So it's burned, right? Or it decomposes. Okay, so a couple of different ways to go from the biosphere to the atmosphere. One is through burning, and one is through natural decomposition, right? But the end result here is melting of permafrost, which then releases more carbon into the atmosphere. Okay, so it's a little bit of one of those positive feedback loops. Okay, so take a look at both of these, adjust yours if you need to. It also has the rest of the questions here as well. Okay, so again, please take some time, go through those. If you have questions, make sure you ask.